Hello everyone. In this video we are gonna explain on the topic the random forest algorithm. So this is basically an extension of the decision tree algorithm. So uh, this is there is nothing new and or special in this algorithm. So it will be a short video. We will also understand how to apply it on sklearn, and so let us just start. So by the end of this video, you will be able to understand the concept of random forest classifier, learn about bagging algorithm, and also apply some random forest algorithm in sklearn along with various tuning parameters. So random forest classifier. So a major problem of the decision tree was the problem of like overfitting and pruning alone, which does not fight it completely. So you understood the concept of decision tree earlier. So a major problem was like overfitting the model. So it would be just if pruning is not done properly, so our decision tree will keep splitting until it reaches the peon node, which would which would create a lot of problems in terms of the overfitting of in creating the overfitting model. So therefore in this classifier a combination of decision tree is used and the majority voting is done for the final prediction. So this second point summarizes the entire algorithm. So I will just explain it. Wait a minute. We also need to ensure that X train for each decision tree training is sufficient. Also, bagging means bootstrap aggregation algorithm. It says that out of m data points, we select m points with replacement and repetition allowed. So this is basically the statement of bagging algorithm. So let us just see what all this means exactly. So suppose this is our original data set in which we are having 4 columns and 5 rows. So what we do is we create more such data sets by eliminating. Suppose we have eliminated f3 here. We are in this data set we have eliminated again f3, but we have repeated the id2, which is d and e. You can see that we have eliminated j and k. Here we have eliminated f2 feature. Here we have eliminated f1 feature, and again here we have repeated the first point, and here we have repeated nothing. So what we are doing basically, so this is known as bagging. So with repetition allowed, we are selecting m data points again and again. We are doing this. So what we would do basically is that we will create a decision tree pertaining to this particular column, and then again we will create another decision tree which will give some output based on this data set. Then again we will create another decision tree. Similarly, we will create multiple decision trees. uh, then what we will do a majority voting. Suppose this decision tree says yes, this says yes, or 0 1. Suppose 1 1 1 and 0 0. So 3 ones and 2 zeros if we get from all the decision trees, so we will say that the majority thing is 1 basically. So that would be a random forest. So why the name random forest basically suggests is a forest is what basically a combination of multiple trees. So the same concept is used here. So there is an example which you can see here. So this is the original dataset, which is just bootstrapped by removing the age column. Here they have removed the smoker column, and here they have removed the country column. So these creates a further datasets, further decision trees basically, and then we do the majority voting among whatever the whatever classification is being done by each decision tree. So there are many arguments in the sklearn module of this decision tree. So basically it is a portion of the ensemble module. So I will just suggest you to go through this scikit-learn. So you of course you don't need to type this link from the video. You can just search sklearn ensemble decision tree classifier documentation. So you should go to this documentation to see the various arguments available for the random forest. We can also choose the number of decision trees we want, set the maximum depth of decision tree, and etc stuffs. So we just import the necessary libraries, import numpy as np, sklearn.ensemble import random forest classifier. This is the classifier which we are going to work upon. We also need to import dataset and tree. We are also importing model selection for the train test split purpose. We are also importing feature selection for to select from model, and the matrix accuracy score import pandas and display image. So this image is basically for maybe it is not required for this one purpose. So we are basically working on the iris dataset. You can create an image also, like the thing we did during our decision trees, sklearn. So this iris dataset we will first load, then we will create the features, and then the x and y values, and then we will do the train test split, x train y, x test, y train y test, train test split of x. You can mention the test size, and random state, let's say it's 14. So random state is basically done if you want the same result to happen again and again each time you run the code. So this specific, otherwise it would be just random. Now we create an object handle of classifier with random forest classifier. N estimators means in this algorithm the computer will create 10,000 trees, 10,000 decision trees it would get, and then it would take a majority vote. So you can from a bit of intuition you can also say that this will give a much higher accuracy than decision trees. Also there would be like no generic case, so there will be less overfitting our model. So you can just go through what does n jobs means, and random state I already explained through the sklearn documentation. Now we just fit the model through our classifier. So whatever classifier object handle we have created, we are just fitting the model through the x train and y train. And now we can see the score is that we have got a 95% accuracy on our prediction. So you can also plot the feature importance, something known as feature importance. So in a data frame you can just set the index as features, and clf dot feature importances will give what is the contribution of each feature, what is the importance of each feature in prediction or in making split. So you can see that petal width has a very high importance. So using the petal width we can get, we basically obtain most of the portion of our accuracy in our model. So that's the most important feature. So making a classifier picking by only important features, so you can also make a classifier by picking only the important features so as to create less overfitting, and to create was basically the to increase further accuracy and stuff. So these things you will also get in the documentation. So sfm you can just create another file object handle, select from model. You can use the earlier classifier and set the threshold as 0.15. So picking only those features that have importance values greater than 0.15. So it would just pick the petal width and petal length. Other less important stuffs it will just ignore, and sfm dot fit, then we fit the model. Then the train test we do the important like we create the x test and x train through this. We just transform basically. So this x train and x test we have obtained by using the train test split on our initial data. Now we are transforming it to our new object handle, because this is the object handle obtained by selecting the only the important features. So we are just creating a variable with name x important train. So the x important train shape has, you can see the shape and stuffs, and also x train and x test you can see. Then the new random forest classifier with only important features. So you can understand that the clf important random forest classifier. So this is the new classifier handle. Then we can easily fit the model using x important train and y train. So y train of course will be the same. There is no meaning of changing it. And then you can see the score obtained earlier was 95%, but this time it is 96.67%. So you see, by selecting the important features you can get to more accuracy. So accuracy is a stuff in random forest which is of prime importance. For regression we use mean instead of majority voting, and on each node we do the splitting on whichever give the max decrease in MSE. So for regression in there is also something known as random forest regressor, right? So these are all the classification algorithm. For regression we use mean instead of majority voting. So on each node how we will do the split. So we will see that which split, instead of the gain ratio, we'll see that which split gives us the maximum decrease in the mean squared error. So whichever will give me the maximum decrease in error, I will select that one. So the compared to the decision trees, random forest classifier give a worst accuracy on the training dataset, but give a far better accuracy on the testing dataset. So we are only concerned about the testing dataset, right? So if you create a model, the training dataset won't matter much because it is only for a one-time use, but again and again if you use on the testing dataset, random forest classifier will give a far better result. So yeah, that's all from this video. Meet you in the next video. Till then, take care. Thanks a lot.